In this section, we'll be talking about area and perimeter of parallelograms and triangles. So first, to talk about the parts of these shapes, we have a parallelogram has a base and a height. And the base and the height need to be perpendicular to each other, meaning they have to create that 90-degree angle at their intersection. The triangle is actually very similar. The base and the height also need to create that 90-degree angle at their intersection. Okay, so that is the main part of identifying these parts of the shape, and then it's all substituting into the formula from there. So the area of is the region where nothing is overlapping. So you have dealt with area before, so we are just applying this into triangles and parallelograms. Now, the area of a parallelogram is the product of the base and the corresponding height. So we talked about that already. This would be my base, and I have to make sure that my height is perpendicular to it. I would not want to use this slanted piece. This is not going to be the height of my parallelogram. So just be careful with the numbers that you are using. So let's jump right into some examples then. Find the perimeter and the area of Rstu. Now, we don't necessarily go over perimeter in this set of notes, so I'm going to talk about that really quick. The perimeter is all sides added up together. Okay, so you would just add kind of like you're walking around the shape, how far you would walk around, that would be the perimeter. So let's go ahead and do that first. My perimeter in this case would be 32 plus the 20, and then the sides repeat themselves. So it would be another 32 and then another 20, okay? And the perimeter in this case is going to be 104 inches. So that's my perimeter distance all the way around. Now, for my area, I actually have to do a little bit more work because remember, the area is the base times the height. Well, the base translates, the base is the same, it's going to be 32. But the height, we don't know the height in this case. We need to figure out what this height is. So I'm going to draw my little triangle off to the side here. And I know that this part is 12. They're giving me enough information to kind of build my triangle. I don't know the height, but I do know that this height is going to be 20 because we know about parallelograms that the opposite sides are congruent. That's something we learned back in chapter 6. So I know that I can say that if one side is 20, the other side is 20. So to find the missing side here, I have to use the Pythagorean Theorem. A squared plus b squared equals c squared. So in this case, we can just call a x, b is going to be 12, and c is going to be 20. So we subtract the 12 squared over, and make sure you're using a calculator for this part. I get x squared. Well, I'm going to skip the step and just say that x equals 16. So I took the square root of 256, which was the value there. So I did all that work to figure out that the height is 16, and that's going to help me figure out that the area is 512, and it's going to be inches squared. So this is important to note that perimeter is going to just be in units, and the area is going to be in those units squared. So please make sure you are labeling them correctly. Okay, let's keep going with some more examples again. Using the base and the height is how we're going to find the area of these parallelograms. So first, the perimeter. The perimeter is these sides added up together. So 27 plus the 17, which remember transfers over here. This base is also going to be 27, so don't be confused with that 8. The 8 is important, but not necessarily for the perimeter. When I add these up, I get 88, and these are, oh, not inches, but meters this time. Okay. Now, same thing, I'm going to have to bring this triangle over. I'm looking for the height, and I'm going to use a squared plus b squared equals c squared. Okay. So we can call a x again if we want. B is going to be 8. And the c is going to be the hypotenuse, right? Because this is a 90-degree angle and this is a cross, so that's my c value. When I go ahead and solve for x, I get that x equals 15. So that's going to be the height of my parallelogram here. So the area is the base, which we established was 27, and the height, which I just found, is 15, giving me an area of 405 meters squared. Don't forget those units. The area is squared. And lastly, we have another parallelogram, but we are really reviewing here because we need to use special right triangles to figure out what the height is going to be. So this is going to be 9, and let's take it back to, well, first let's find the perimeter. That's the easy one. 12 plus 9 plus 12 plus 9. And so we're going to have to, the perimeter there is 42. That's just units. We don't have specific units on this one. But thinking back on special right triangles, this is going to be a 45, 45, 90 special right triangle. So let me take you back to that section, chapter 8. This is H, and this would also be the same because we're dealing with a 45, 45. So our ratio, remember, was 1 to 1 to square root of 2. And what I'm going to do is I'm going to call this X for now, a proportion where I can cross multiply and solve. So if I set up 1x equals square root of 2 over 9, and I cross multiply, I get square root of 2x equals 9, and then I divide by the square root of 2. Okay? So for now, I'm going to leave it as the square root of 2. That's going to be 9 divided by the square root of 2, my height. And so my area is base times height. My base is 12. My height happens to be 9 over the square root of 2. And I'm just going to ask you guys to please put that into your calculator. So use parentheses, and don't forget this is second x squared to get that radical there. This gives me 76.37, let's go with that, units squared. Okay, so this one did require us to kind of think about and review how we would do that. So just, don't forget all the math you learned in previous chapters. Okay. Moving on, just one more example. Find the area. So very similar here. We know that this is going to be 12. We are looking for the height. And then going off of that, so same process, we have 1 to 1 to square root of 2 for my ratio. The height I'm just going to call x. Across the 90-degree angle is 12, and then I'll cross multiply. So I get x square root of 2 equals 12, and then I divide both sides by the square root of 2. So I get x equals, let's see here. I did not simplify that one, so we're just going to leave it as 12 square root of 2. My area in this case is base times height. I don't need to find the perimeter this time, just the area. So base is 16. My height is 12 over square root of 2, and then I can put that into my calculator. When I put that into my calculator, I should get 135.76, and that's centimeters squared. So these are a little bit more difficult, so just take it slow and remember your special right triangle ratios. That's going to be really helpful. In this next one, we have another special right triangle, and this time it's a 30, 60, 90. So our ratio for that one is 1 square root of 3, 2. 2 is across my hypotenuse, which in this case it's going to be 5. And then the 60 angle is here, so that's going to be across my height that I'm looking for. So I'm going to call that x. And then setting up my proportion, I'll be able to solve for x here. Cross multiply, we get 2x equals 5 square root of 3. And then I would divide both sides by 2 to get x. So the height is 5 square root of 3 over 2. So to find the area, and I'm going to be using my calculator here. Remember, it's base times height. My base is 11. My height is 5 square root of 3 over 2 Please be careful using that. Put it on your calculator. Make sure you're using the parentheses needed. But you should get 47.63 meters squared. Remember, the units are being squared for these. Okay? All right, now we're going to go on to those triangles. In the triangles, we have to also identify the base and the height. Remember, the base and the height need to make that 90-degree angle. They need to be perpendicular to each other. So if you're not seeing a 90-degree angle, you probably need to do a little bit more math to find the height. Okay? So this very first example here, we have you need to buy enough boards to make the frame of a triangle sandbox shown and enough sand to fill it. So enough sand to fill it is going to give me an idea that I need the area. I need to figure out how much surface it's going to cover. If one board is 3 feet long and one bag of sand is 9 square feet, fills 9 square feet, how many boards and bags do you need? So first, the board is going to be used to contain the sand, right? So the boards being 3 feet long are going to help me figure out my perimeter. So I need to figure out how far around do I need to enclose the sandbox. So my frame, I'm going to be using the perimeter. How much do I need to go around? In this case, my perimeter is 16 plus 7.5 plus 12. And when I do that, I get 35.5. Now, this is the full perimeter, but I need to figure out how many boards to buy to make this happen. So when I do 35.5 divided by 3, let's see, 35.5 divided by 3, because each board is 3 feet long, I get 11.8. Now, you can't just buy parts of the boards. You have to buy full ones, right? So I'm going to round up to 12 boards total. So 12 boards are going to help me enclose this triangular sandbox. Then I have to figure out how much sand to buy. So to do that, the sand to fill, I need to figure out the area of this triangle because it's telling me that a bag fills 9 square feet. Okay, so to find the area of this triangle, I'm using my 1/2 base times height formula. Well, my base is down here. This is my base, which is 12. And the height, here's where you need to identify that piece that's going to be perpendicular. So that's 7.1. Now, not always will they give it to you. You might need to use the Pythagorean Theorem to go backwards and go from there. But when I enter this, I get 42.6 as my area. That's not your answer though, because we need to figure out how many bags of sand to buy. So if each bag fills 9 square feet, when I do that, I'm going to get, let's see, 42.6 divided by 9, 4.7. So again, you can't just buy 4 bags in a little bit. So I'm going to find 5 bags of sand to fill my box. And that's your answer. Okay. All right, and the last example here, find the perimeter and area of triangle ABC with these given vertices. So to find the perimeter and the area, I'm going to need to do some math here. My area, in this case, is actually going to be the easiest, and the perimeter is going to be the more difficult one because I have to use the distance formula. So to do the area, I'm going to do 1/2. This is going to be my base, so just count how many units. 5, 6, 7, 8 units for my base. Okay, and then your height is going to be perpendicular, so just make sure they create that nice box. So that's 1, 2, 3, 4. Okay, when I do that, oh, and I just caught myself here because we need to be really careful before I do the math. Notice how these units are, each box is 2 units. So I almost made the mistake. Thankfully, I caught myself. Each of them is going up by 2. So even though we want to call this 8 units, this is actually 16 because they go up by 2. So this is actually 8. So be super careful. I almost missed that. And that gives me 64 units squared. Okay. So there, my area was pretty easy this time. Now I have to find the distance so that I can find the perimeter. So this is still 8, that doesn't change, but I do need to figure out what AB is going to be. And so I need to do my distance formula for AB. So remember that when you take the x's, subtract them, square them, and then add the difference of the y's. So -2 squared. When I do AB, I get the square root of 128. I'm just going to leave it like that. I'm going to do the same thing for AC. So square root of -4 minus 4 squared plus 6 minus -2 squared. And I should get the same thing, square root of 128, okay? So when I do this, my perimeter is going to be my original side. The CB I didn't do because thankfully that one's flat and it's just 8 units. So to get my perimeter, I need to add all of these up. Square root of 128 plus square root of 128 plus 8. And putting that in my calculator and rounding appropriately, 38.6 units is my perimeter. So if you're doing this on your own, just be super careful with that distance formula. But that would answer both of my questions. And that is the end of this video, 10.1, finding the area of parallelograms and triangles.